For our last problem here, or our last two problems, our next one we have the fourth root of 32 plus the square root of 32. Fourth roots, as I mentioned in our previous section, are kind of tricky to split up. Usually with fourth roots, you're looking for either 16 or 81. In this case, we're looking for 16. We would have the fourth root of 16 times the fourth root of 2, and the fourth root of 16 is 2. So we have 2 times the fourth root of 2. The next one's a square root. We're still going to split it up into 16 and 2, but this time it's square roots. And the square root of 16 is 4, so we have plus 4 square root of 2. Now these, even though they have the same thing under the root, they're not like terms because one's a fourth root and one's a square root. So we stop here. We can't combine them because they're not like terms. That's the final answer. So now let's take a look at our last problem for this section. Here we have the cube root of 8y to the fifth. So when we're doing the cube root of 8, that's 2. For the cube root of y to the fifth, 3 doesn't go into 5 evenly, so we're going to have part not under the root, part under the root. 3 goes into 5 once with a remainder of 2, so we're going to have y to the first, cube root of y squared. When we do this with the next one, the cube root of 27 is 3, and we've got the same problem we had a minute ago. So that's also going to be y to the first cube root of y squared. So these have the same variable part and the same root part. That means they're like terms, so we combine them by adding the numbers at the front, and we would have 5y cube root of y squared.